Look up at the night sky, where a faint red dot glows among countless stars. That's Mars, the red planet, a world that seems cold, barren, and lifeless today. But what if I told you it wasn't always this way? Billions of years ago, Mars was a different place. Rivers carved deep valleys across its surface, lakes shimmer under a thick atmosphere, and clouds drifted in skies that might have mirrored Earth's. It was a planet brimming with potential, a world that could have been home to something or someone. Then, something changed. The rivers dried up, the air vanished, and Mars became a cosmic graveyard, its secrets buried in red dust. Or so we thought. NASA's rovers have been scouring the Martian surface for decades, and what they've found is nothing short of astonishing. Ancient riverbeds snake through the landscape, hinting at a watery past. Organic compounds, the building blocks of life, lie hidden in the soil. Strange structures, some say, unnatural. The planet's surface, defying easy explanation. Could these be the remnants of life, not just simple microbes, but an advanced civilization that thrived long before humans ever gazed at the stars? Or is there something more, something NASA knows, but isn't telling us? In 1976, a photograph from Mars sent shockwaves through the world. Captured by NASA's Viking 1 spacecraft, it showed a structure in the Cydonia region that looked eerily like a human face, staring out into the void. Scientists dismissed it as a trick of light and shadow, a natural rock formation playing games with our imagination. But others weren't so sure. What if this face on Mars was no accident? What if it was a message, a monument left behind by a lost world, waiting for us to find it? Today, we're embarking on a journey to uncover the truth about Mars. From ancient oceans to mysterious artifacts, from unexplained methane spikes to secrets locked away in NASA's vaults, we'll explore every clue that points to life on the red planet. Was Mars once a thriving world, home to beings we can only imagine? Are the answers buried in the data, or hidden in plain sight? Stay with us until the end, because we're about to reveal a theory so bold, it will change how you see Mars forever. This is no ordinary story, it's a cosmic mystery that demands answers. Let's dive in and discover what Mars is hiding. Subscribe Zebo Alien now to join the quest for the truth. Imagine stepping onto a world where the sky glows with a soft blue hue, where rivers wind through lush valleys, and where clouds drift lazily above a landscape that feels hauntingly familiar. This isn't Earth, this is Mars. Billions of years ago, a planet so vibrant, so full of potential, that it might have been a mirror of our own world. Today, we think of Mars as a desolate, red wasteland, its surface scarred by dust storms and craters, its air too thin to breathe. But the story of Mars begins long before it became the barren world we know. To understand the mysteries it holds, we need to travel back in time, to an era when Mars was alive, pulsing with possibilities that could rewrite everything we believe about life in the universe. Let's set the stage. 4 billion years ago, Mars was a very different place. Scientists tell us it had a thick atmosphere, rich with gases that trapped heat and kept the planet warm. Water flowed freely across its surface, not just trickles, but mighty rivers that carved deep channels and fed vast lakes, some as large as Earth's Great Lakes. There were oceans, too, or at least one massive body of water that might have covered the planet's northern hemisphere. Picture it: waves lapping against rocky shores, rain falling from a cloudy sky, and perhaps, just perhaps, something stirring in those ancient waters. This wasn't a barren desert, this was a world that could have supported life, a world that might have been home to something extraordinary. How do we know this? The clues are etched into the Martian landscape, preserved like a cosmic time capsule. NASA's missions, starting with the Mariner 9 spacecraft in 1971, gave us our first close-up look at Mars. Unlike earlier flyby missions, Mariner 9 orbited the planet, mapping its surface in stunning detail. What it found was staggering: a canyon system so vast it dwarfs anything on Earth. Valles Marineris, often called the Grand Canyon of Mars, stretches over 4,000 kilometers long, enough to span the United States from coast to coast. Its walls plunge up to 11 kilometers deep, carved by forces that hint at a planet once teeming with activity. These weren't just random cracks in the ground. They were the scars of a world shaped by water, wind, and possibly something more. The evidence for water is overwhelming. When Mariner 9 beamed back images of dry riverbeds, Scientists were stunned. These weren't vague markings, clear channels with branching patterns that looked exactly like river systems on Earth. Some channels showed signs of catastrophic flooding, as if massive torrents had roared across the planet, reshaping its surface in a matter of days. Others were gentler, meandering paths that suggested steady rivers flowing for centuries. In the planet's northern lowlands, vast plains bear the smooth, flat signatures of ancient lake beds or even an ocean floor. The Cydonia region, for example, holds evidence of a lake larger than any on Earth, its shores marked by mineral deposits that form only in the presence of water. These discoveries, confirmed by later missions like Viking, Mars Global Surveyor, and Mars Odyssey, paint a picture of a planet that was once wet, warm, and inviting. But water alone doesn't tell the whole story. Mars had an atmosphere thick enough to support liquid water on its surface, something impossible in today's thin, frigid air. Scientists believe Mars once had a magnetic field generated by a molten core that shielded the planet from the harsh radiation of space. This magnetic field would have protected the atmosphere, keeping it dense and stable. Over time, however, that field weakened. The atmosphere began to leak away, stripped by solar winds. Without protection, the water evaporated or froze, leaving behind a dry, cold world. But what caused this dramatic change? Was it a natural process, a planet simply aging and losing its vitality? Or could something else have disrupted Mars, something that left traces we're only now beginning to understand? Let's pause to consider what this means. A planet with rivers, lakes, and an atmosphere like Earth's raises profound questions. If Mars was once so hospitable, could it have supported life? On Earth, wherever we find water, we find life, microbes in deep-sea vents, algae in Arctic ice, even bacteria in scalding hot springs. If Mars had water for millions of years, why wouldn't life have taken root there? And if it did, what kind of life was it? Simple organisms, like the microbes that first appeared on Earth? Or something more complex, something that could have built structures, left artifacts, or even gazed at the stars as we do now? The possibility is tantalizing, and the clues are there, waiting for us to piece them together. The Mariner 9 mission didn't just reveal water. It showed us a planet with a violent past. Mars is home to the largest volcano in the solar system, Olympus Mons, a behemoth 3 times taller than Mount Everest. Its massive shield volcanoes, like those in the Tharsis region, suggest intense geological activity billions of years ago. Lava flows, some still visible today, hint at a planet that was geologically alive, with molten rock shaping its surface. But these volcanoes also raise questions. Could their eruptions have altered the climate, pumping gases into the atmosphere or triggering catastrophic changes? Or were they a symptom of something deeper, perhaps tied to forces we don't yet understand? Then there are the craters, millions of them, sparring Mars like a cosmic battleground. Unlike Earth, where erosion and plate tectonics erase craters over time, Mars preserves them, offering a window into its ancient history. Some craters, like those in the Hellas Basin, are massive, stretching hundreds of kilometers wide. Others are smaller, peppered across the surface like bullet holes. These craters tell us Mars was bombarded by asteroids and comets, especially in its early years during the late heavy bombardment, a chaotic period when debris rained down across the solar system. Could these impacts have brought the building blocks of life to Mars, as some scientists believe they did on Earth? Or could they have wiped out whatever life might have existed, leaving only ruins behind? Let's take a step further into the unknown. If Mars was once a living world, what happened to it? The loss of its atmosphere and water is a tragedy on a planetary scale, but the details are murky. Some scientists point to natural causes. The planet's small size meant it couldn't hold on to its magnetic field, leaving it vulnerable to solar winds. Others suggest more dramatic events, a massive impact, perhaps, or a sudden shift in the planet's core. But there's another possibility, one that lingers on the edges of science and ventures into the realm of speculation. What if Mars didn't just die on its own? What if something or someone played a role in its downfall? This brings us to the heart of the mystery. The evidence for a wet, warm Mars is undeniable, but it's the implications that grip our imagination. If life existed, what form did it take? Could there have been creatures swimming in Martian seas, building structures on its shores, or even traveling between worlds. The idea of an ancient Martian civilization isn't just science fiction, it's a hypothesis that grows more compelling with every discovery. The riverbeds, the lakes, the volcanoes, the craters, they're not just geological features, they're pieces of a puzzle, hinting at a story far greater than we've been told. Consider the scale of Valles Marineris again. It's not just a canyon, it's a monument to a lost world. Its walls, towering kilometers high, could hide secrets we've yet to uncover. Some researchers, standing on the fringes of mainstream science, have suggested that the canyon's formation might not be entirely natural. Could it be the result of tectonic forces we don't fully understand? Or could it hint at artificial processes, the work of a civilization capable of reshaping a planet? These ideas may sound far-fetched, but Mars has a way of defying our expectations. Every mission, from Mariner 9 to Curiosity, has revealed something new, something that pushes the boundaries of what we believe is possible. Let's zoom out for a moment. Mars wasn't an isolated world. It was part of a young solar system, surrounded by other planets forming and evolving. Earth, just one orbit away, was also developing life during this time. If life arose on Earth in warm, wet pools, why not on Mars? The two planets were like siblings, born from the same cosmic materials, bathed in the same sunlight. If microbes could thrive in Earth's primordial oceans, couldn't they or something more advanced have flourished on Mars? And if they did, what traces did they leave behind? Fossils, artifacts, or something so alien we wouldn't even recognize it? The data keeps piling up. NASA's Mars Global Surveyor mapped the planet's magnetic field, revealing patches of magnetism in the crust remnants of an ancient dynamo that once shielded Mars. These magnetic anomalies, found in places like Terra Serenum, suggest a planet that was once protected, much like Earth is today. But when that shield failed, Mars was exposed. The atmosphere thinned, the water vanished, and any life that existed would have faced a brutal end. Yet some clues suggest not everything was lost. Mineral deposits, like those found in the Eridania Basin, show signs of hydrothermal activity. Hot springs that could have been oases for life even as the planet dried out. On Earth, such environments teem with microbes. Could Mars have harbored similar ecosystems, clinging to survival in its final days? The more we learn, the more questions arise. The ancient riverbeds, some as wide as the Mississippi, suggest water flowed for millions of years. That's not a fleeting moment, it's enough time for life to evolve, adapt, and perhaps build something lasting. The Mars Odyssey mission detected vast deposits of water ice just beneath the surface, especially at the poles. If ice remains today, imagine how much liquid water once covered the planet. Some estimates suggest Mars had enough water to cover its entire surface in an ocean 100 meters deep. That's not a puddle, it's a world of possibilities. But let's push the boundaries further. What if Mars wasn't just a cradle for life, but a hub for something greater? The idea of a Martian civilization, advanced enough to leave traces we're only now discovering, isn't as crazy as it sounds. On Earth, human civilizations rose and fell, leaving pyramids, temples, and cities buried beneath sand and time. Could Mars have a similar story, hidden beneath its red dunes? The Mariner 9 images sparked this idea, and they revealed not just canyons, but strange formations, mounds, ridges, and patterns that some claim look too regular to be natural. These features, scattered across regions like Cydonia and Elysium, fuel speculation that Mars holds more than geological relics. Let's explore one such anomaly, the so-called D&M Pyramid in the Cydonia region, named after its discoverers, DePietro and Molinar. This five-sided structure, visible in early NASA images, looks eerily like a pyramid or platform. Mainstream scientists call it a natural mesa, eroded by wind and time. But its geometric shape and proximity to the face on Mars have inspired bolder theories. Could it be a monument, a marker left by an intelligent species? The idea gained traction in the 1980s when researchers like Richard Hoagland argued that Cydonia was a planned complex with alignments suggesting intentional design. While NASA dismisses these claims, the debate persists, fueled by the human need to find meaning in the unknown. This brings us to a critical point. Mars challenges our assumptions about life, intelligence, and our place in the cosmos. The evidence for a wet, warm past is solid riverbeds, lake beds, mineral deposits, and atmospheric traces all confirm it, but the leap to life, especially intelligent life, requires us to think beyond what we know. If Mars was habitable for millions of years, it had time to nurture not just microbes, but complex organisms, perhaps even societies. On Earth, life evolved from single-celled organisms to dinosaurs to humans in roughly 4 billion years. Mars had a similar window. What could have emerged in that time? The loss of Mars' atmosphere is a key piece of the puzzle. Scientists believe the planet's small size, about half the diameter of Earth, meant it couldn't sustain a strong magnetic field. Without that shield, solar wind stripped away the atmosphere, turning Mars into the frozen desert we see today. But the process wasn't instantaneous. It took millions of years, perhaps longer. During that time, any life on Mars would have faced increasing challenges: dwindling water, dropping temperatures, and rising radiation. Could some species have adapted, retreating to underground aquifers or geothermal pockets, or could they have left, seeking refuge on another world? This idea isn't as far-fetched as it seems. The concept of panspermia, the transfer of life between planets, suggests that microbes could have traveled from Mars to Earth, or vice versa, carried by meteorites. Some meteorites found on Earth, like the famous LHA-401, originated on Mars and contain microscopic structures that some scientists believe could be fossilized bacteria. While the debate over LHA-401 continues, it raises a stunning possibility. Mars and Earth might share a biological history. If life existed on Mars, it could be our distant ancestor or our distant cousin. Let's linger on that thought. If Mars was a living world, what kind of life was it? Simple microbes, clinging to warm pools, or something more advanced, capable of building structures, harnessing energy, or even traveling through space? The Mariner 9 images, with their hints of unnatural formations, keep this question alive. The Cydonia region, in particular, has become a lightning rod for speculation. Beyond the face and the D&M pyramid, there are other features: mounds aligned in patterns, ridges that seem too precise. These could be natural, shaped by eons of erosion. But what if they're not? What if they're the remnants of a civilization that thrived when Mars was green? To explore this, let's consider the science. The Mars Global Surveyor and Mars Reconnaissance Orbiter have mapped Mars in unprecedented detail, revealing features that defy simple explanations. In the Neely-Fossey region, for example, scientists found clay minerals, smectites, that form only in the presence of water. These clays suggest long-term wet environments, stable enough to support life for millions of years. In Gale Crater, where curiosity roams, layered sediments point to ancient lakes that persisted for centuries. These aren't fleeting conditions. They're the kind of environments where life could thrive, evolve, and perhaps build. But building what? On Earth, early humans left stone tools, cave paintings, and eventually cities. If Mars had intelligent life, what would they leave behind? Stone structures would erode under Martian winds, but metal or composite materials could survive. Some researchers, like those inspired by Hoagland's work, suggest that certain Martian features like the tips and meteorites seem to hold their images could be artificial. These tube-like structures, possibly lava tubes, have sparked debate about whether they're natural or engineered. Could they be tunnels, shelters, or even transport systems built by an ancient race? Let's take a step back. The idea of a Martian civilization is speculative, but it's grounded in the reality of Mars' past. The planet had water, an atmosphere, and time, billions of years for life to emerge and evolve. The Mariner 9 mission, which first revealed the scale of Valles Marineris, also showed us a planet with a complex history. Its volcanoes, like Olympus Mons, erupted for millions of years, reshaping the surface and possibly the climate. Its craters, like those in Hellas, record a violent past of cosmic collisions. These features aren't just geological, they're a canvas for speculation. What if the forces that shaped Mars weren't all natural? What if intelligent hands guided some of those changes? The Viking missions in the 1970s added more fuel to the fire. Their images of Cydonia, including the infamous face, sparked a cultural phenomenon. Books, documentaries, and even movies explored the idea that Mars was more than a dead planet. While NASA insists these features are natural, the public's fascination endures. The Mars Reconnaissance Orbiter later provided high-resolution images showing the face to be a weathered hill. But the debate didn't end. Some argue that erosion could have obscured artificial structures, blending them into the landscape. Others point to nearby features, like the D&M Pyramid, as evidence of a larger complex. This brings us to a deeper question. Why are we so drawn to these ideas? Mars feels like a lost sibling, a planet so close to Earth that it's hard to believe it was lifeless. The Mars Odyssey mission detected water ice beneath the surface, enough to fill vast oceans if melted. The Curiosity rover found evidence of ancient streams in Gale Crater, with pebbles rounded by flowing water. These discoveries aren't just scientific, they're emotional. They make us wonder what might have been, what might still be hidden beneath the red soil. Let's consider the timeline. Mars was wet and warm during the Noachian period, roughly 4.1 to 3.7 billion years ago. This was a time when Earth's first microbes were forming in primordial pools. If life arose on one planet, why not the other? The Noachian era saw intense volcanic activity, with Tharsis volcanoes pumping gases into the atmosphere, possibly creating a greenhouse effect that kept Mars warm. The Hellas Basin, formed by a massive impact, could have been a cradle for life. Its warm, wet floor ideal for microbes or even more complex organisms. As the planet cooled, life would have faced challenges, but it could have adapted, much like extremophiles on Earth survive in harsh conditions. The Mars Global Surveyor found evidence of layered sediments in places, Ikander Chasma, part of Valles Marineris. These layers, built up over millions of years, suggest cycles of flooding and drying. On Earth, such sediments often contain fossils. Could Mars layers hold similar treasures? The Curiosity rover has drilled into these sediments, finding sulfur, nitrogen, and carbon, key ingredients for life. While no definitive fossils have been found, the possibility remains. If Mars had life, it might not look like Earth's. It could be alien in ways we can't yet imagine, leaving traces we wouldn't recognize without advanced technology. This brings us to the edge of science and into the realm of wonder. If Mars supported life, could it have been intelligent? The Mariner 9 images of Valles Marineris show features that some call terraced walls, with steps and ridges that look almost engineered. Mainstream science attributes these to erosion, but the patterns are striking. In Elysium Planitia, strange mounds form geometric shapes, visible in orbiter images. These could be natural, but their regularity invites questions. What if Mars was home to beings who built cities, canals, or even starships? What if they left, driven away by dying planet, or stayed hidden in underground bunkers? The idea of a lost Martian civilization isn't new. In the 19th century, astronomers like Percival Lowell observed what they thought were canals on Mars, evidence of an advanced society. Modern telescopes debunk these as optical illusions, but the dream persists. The Mars Reconnaissance Orbiter has found evidence of seasonal water flows, briny streaks called recurring slope linea that suggest liquid water still exists on Mars, perhaps in small amounts. If water persists, could life? And if life persists, could it be more than microbial? Let's explore this further. The Viking landers conducted experiments in the 1970s to detect life. One experiment, the labeled release test, produced results that some scientists, like Gilbert Levin, believe indicated biological activity. The official conclusion was that chemical reactions, not life, caused the results. But the debate lingers, especially as new missions find more evidence of water and organics. The Curiosity rover's discovery of methane spikes bursts of gas that could come from microbes or geological processes adds another layer. On Earth, most methane is biological. Could Mars be hiding similar life forms deep beneath its surface? The Mars Odyssey mission also found hematite deposits, often formed in water-rich environments. These blueberries, as scientists call them, litter the Meridiani Planum, where the Opportunity rover explored. They're another sign that Mars was once wet, perhaps for millions of years. The Perseverance rover, now exploring Jezero Crater, is collecting samples that may hold the key to these questions. Scheduled for return to Earth in the 2030s, these samples could contain fossils, chemical signatures, or even evidence of something more advanced. But what if the evidence is already in NASA's hands, locked away in classified archives? This brings us back to the big picture. Mars was a living world, with water, warmth, and time to nurture life. Its rivers, lakes, and oceans were more than geological features, they were potential cradles for evolution. The Mariner 9 mission opened our eyes to a planet with a rich, complex past, one that challenges our understanding of life's possibilities. Whether it was microbes, complex organisms, or an advanced civilization, Mars holds secrets we're only beginning to uncover. As we move forward in this journey, we'll dive deeper into the evidence, organic compounds, methane, and strange structures that suggest Mars was more than a dead planet. The story of ancient Mars is just the beginning, and the truth may be stranger than we ever imagined. The story of Mars is a tale written in stone, dust, and whispers of a lost world. In our journey so far, we've seen a planet that once pulsed with life's potential, rivers carving its surface, lakes shimmering under a thick atmosphere, and vast canyons hinting at a vibrant past. But the question that haunts us is this: did life ever take root on the red planet? Not just fleeting microbes, but something more, perhaps a civilization that left traces we're only now beginning to uncover. To answer this, we need to dig deeper, to follow the clues left by NASA's rovers and orbiters, clues that point to water, organic compounds, and strange chemical signals that defy easy explanation. These are the building blocks of life, the pieces of a cosmic puzzle that might reveal whether Mars was ever home to something alive, something aware, something watching the stars. Let's start with water, the elixir of life. On Earth, wherever we find water, we find life, microbes thriving in scalding hot springs, algae clinging to Arctic ice, bacteria burrowing in deep-sea vents. If Mars once had water, as we explored in its ancient past, it's not a stretch to imagine life taking hold. The evidence for water is no longer a hypothesis. It's a fact, carved into the Martian landscape and confirmed by decades of exploration. NASA's Curiosity rover, roaming the rugged terrain of Gale Crater since 2012, has given us some of the most compelling proof. Gale Crater, a 154-kilometer-wide basin formed by an ancient impact, was once home to a lake, perhaps for millions of years. The rover's instruments found rounded pebbles, smoothed by flowing water, embedded in layers of sedimentary rock. These aren't random stones, they're the kind of pebbles you'd find in a riverbed on Earth, tumbled and polished by steady currents. But Gale Crater is just one piece of the puzzle. The Perseverance rover, landing in Jezero Crater in 2021, explored a site even more tantalizing. Jezero, a 45-kilometer-wide crater, was once a lake fed by a river delta, its waters pooling in a basin rich with clay minerals. These clays, known as smectites, form only in the presence of water, often in warm, stable environments. On Earth, such places are hotbeds for microbial life. Perseverance has been drilling into Jezero's rocks, collecting samples that may hold the key to Mars' past. These samples, slated for return to Earth in the 2030s, could contain microscopic fossils, chemical signatures, or even something stranger. Imagine opening a Martian rock and finding evidence not just of life, but of something that built, thought, or dreamed. The water story doesn't end with ancient lakes. In 2015, NASA's Mars Reconnaissance Orbiter made a stunning discovery: recurring slope linea, or SL, dark streaks that appear on Martian slopes during warm seasons. These streaks, found in places like Gale Crater, are thought to be caused by briny water flowing just beneath the surface. The water is salty, laced with perchlorates, which lowers its freezing point and allows it to remain liquid in Mars' frigid climate. These flows are fleeting, appearing and vanishing with the seasons, but their presence suggests that Mars isn't as dry as we thought. If water still exists today, even in small amounts, could it harbor life? And if life exists now, what might have thrived when Mars was awash with rivers and oceans? Let's dive deeper into the chemistry of life. In 2018, Curiosity made a groundbreaking discovery in Gale Crater: organic compounds, molecules containing carbon, hydrogen, and sometimes oxygen or nitrogen. These are the building blocks of life as we know it. Proteins, DNA, and cell membranes all rely on carbon-based molecules. Curiosity found these organics in 3-billion-year-old mudstones, rocks formed in the ancient lakebed of Gale Crater. The compounds included thiophenes, benzene, and toluene, molecules that, on Earth, are often linked to biological processes. But here's where it gets tricky. Organics can form without life, through chemical reactions driven by heat, radiation, or volcanic activity. So, are these Martian molecules the remnants of life, or just the product of a lifeless planet's chemistry? The answer isn't simple, but the clues keep piling up. Curiosity didn't just find organics, it found them in significant quantities, preserved in rocks that have endured billions of years of harsh conditions. This suggests that whatever process created these molecules was widespread, not a fluke. The rover's sample analysis at Mars and instrument heated the rocks, releasing gases that confirmed the presence of complex organic molecules. Some of these molecules were surprisingly resilient, surviving in an environment bombarded by cosmic rays and solar radiation. This resilience hints at a robust chemical system, one that could have supported life or been produced by it. Then there's methane, a gas that's become one of Mars' biggest mysteries. On Earth, about 90% of methane is produced by living organisms, microbes in wetlands, bacteria in cow stomachs, even tiny creatures in ocean sediments. In 2013, Curiosity detected spikes of methane in Gale Crater, bursts of gas that appear and vanish unpredictably. These spikes, sometimes reaching 20 parts per billion, were far higher than expected. Later measurements confirmed the pattern. Methane levels fluctuate, rising in warm seasons and dropping in colder ones. This isn't a steady background level, it's dynamic, suggesting an active source. But what's producing it? On Earth, methane comes from life or geological processes, like volcanism. Mars has no active volcanoes today, but it could have underground reservoirs or microbial activity hidden beneath the surface. The methane mystery deepened in 2019 when Curiosity recorded a massive spike, the highest ever detected. Intriguingly, the European Space Agency's Trace Gas Orbiter, designed to study Martian gases, didn't detect the same spike from orbit. This discrepancy puzzled scientists. Was Curiosity catching localized bursts, too small to be seen from space? Or is something else at play, perhaps a process we don't yet understand? Some researchers propose that methane could be trapped in subsurface ice or rock, released during warm seasons. Others, venturing into bolder territory, suggest it could be the breath of microbial life surviving in underground aquifers or geothermal pockets. Let's pause to consider the implications. Water, organics, and methane, these are the ingredients of life as we know it. On Earth, they're found together in environments teeming with organisms. Mars, with its ancient lakes, clay-rich deltas, and mysterious gas spikes, seems to be whispering the same story. But the leap from chemistry to life is a big one. Could microbes have thrived in Mars' ancient waters, leaving behind organic traces? Or could something more complex have existed, organisms that evolved beyond simple cells, perhaps even intelligent beings who left more than chemical signatures? To explore this, let's look at the Perseverance mission in Jezero Crater. Jezero is a geological treasure trove, its delta preserving layers of sediment from a time when water flowed freely. Deltas are ideal for preserving fossils, as they trap organic material in fine-grained mud. Perseverance has collected dozens of samples, sealing them in titanium tubes for the Mars sample return mission. These samples could contain microfossils, similar to the 3.5 billion-year-old fossils found in Australia's Pilbara region. On Earth, such fossils are evidence of ancient microbes. If Mars samples hold similar structures, it would be the smoking gun for life. But what if they hold something else, something that suggests not just microbes, but a civilization? This brings us to the edge of science and into the realm of speculation. The organics found by Curiosity are complex, but they're not definitive proof of life. Methane spikes are intriguing, but they could be geological, yet the combination of water, organics, and methane creates a compelling case. Let's imagine a scenario. Billions of years ago, Mars was a thriving world. Microbes flourished in its lakes, perhaps evolving into more complex forms. Over millions of years, could these organisms have developed intelligence, building structures, or technologies we're only now discovering? The idea is bold, but Mars has a way of challenging our assumptions. Consider the Viking missions of the 1970s, which conducted the first direct experiments to detect life on Mars. The labeled Release experiment, led by scientist Gilbert Levin, produced results that stunned researchers. When Martian soil was mixed with a nutrient solution tagged with radioactive carbon, the soil released a gas that matched the signature of biological activity. On Earth, this would be considered evidence of life, but NASA concluded the results were likely caused by chemical reactions, possibly involving perchlorate salts found in Martian soil that can mimic biological signals. Levin, however, stood by his findings, arguing until his death in 2021 that Viking had found life. The debate remains unresolved, but it underscores a critical point. Mars is full of surprises. The Curiosity rover's methane discoveries add another layer. Methane is unstable in Mars' atmosphere, breaking down under ultraviolet radiation within a few hundred years. For methane to persist, something must be replenishing it. Underground microbes could be one source, living in aquifers or geothermal vents. On Earth, such environments support extremophiles organisms that thrive in conditions deadly to most life. Mars could have similar ecosystems hidden beneath its surface. Alternatively, methane could come from geological processes like serpentinization, where water reacts with certain rocks to produce gas. But the seasonal nature of the spikes leans toward a dynamic process, possibly biological. Let's explore the water evidence further. The Mars Global Surveyor and Mars Reconnaissance Orbiter have mapped vast deposits of water ice, especially at the poles. The South Polar Cap alone contains enough ice to cover Mars in ocean 11 meters deep. If melted, subsurface ice has been found in mid-latitude regions, like Utopia Planitia, where the Phoenix lander dug up ice in 2008. This ice suggests that Mars water didn't entirely disappear, it froze or retreated underground. If liquid water persists in subsurface aquifers, as some models suggest, it could provide a refuge for life. On Earth, bacteria live kilometers beneath the surface, powered by chemical energy. Could Mars have similar hidden ecosystems? The Perseverance rover's work in Jezero crater offers more clues. The delta in Jezero is a geological archive, its layers preserving a record of Mars' wet past. The rover's instruments, like Sherlock and Pixel, have detected minerals and textures that suggest prolonged water activity. Some rocks show signs of chemical alteration, likely caused by water interacting with volcanic basalt. These conditions mirror Earth's early environments, where life first emerged. If Mars followed a similar path, its deltas and lakebeds could hold fossilized evidence of ancient organisms or even artifacts of a more advanced species. Let's push the boundaries further. The organics, methane, and water suggest a planet primed for life. But what kind of life? Most scientists focus on microbes, as they're the simplest form of life we know. But Mars had billions of years to evolve. On Earth, life went from single-celled organisms to complex animals in roughly 3 billion years. Mars, with its own billions of years, could have followed a similar trajectory or a wildly different one. Could multicellular organisms have swam in Martian seas? Could intelligent beings have built cities, now buried under red sand? The Viking images of Cydonia, with its face and nearby geometric structures, fuel this speculation. While NASA calls these natural, their shapes pyramids, mounds, ridges hint at something more. The Mars Reconnaissance Orbiter has provided high-resolution images of these features, showing them to be eroded hills, but erosion can obscure details, blending artificial structures into the landscape. Some researchers, like those following Richard Hoagland's work, argue that Cydonia was a planned complex, with alignments suggesting intentional design. While mainstream science dismisses this, the idea persists because Mars keeps surprising us. The Curiosity rover's discovery for rock formation in 2019, dubbed Starfleet, looked eerily like a human-designed symbol. Coincidence? Perhaps, but Mars has a knack for sparking our imagination. Let's consider another angle: panspermia. This theory suggests life could have spread between planets, carried by meteorites. Mars and Earth exchanged material during the solar system's chaotic early years. Meteorites like LH8401, found in Antarctica, originated on Mars and contain microscopic structures that some believe are fossilized bacteria. While the scientific community remains skeptical, the possibility that Mars seeded life on Earth or vice versa adds a thrilling dimension. If life existed on Mars, it might share a common origin with us, making Martians our distant relatives. The Perseverance mission brings us closer to answers. Its samples, collected from Jezero's delta, could contain definitive evidence of life. But what if that evidence isn't microbial? What if it's a fragment of something artificial, a tool, a machine, or a message? The Mars Sample Return Mission, a collaboration between NASA and the European Space Agency, aims to bring these samples to Earth by the early 2030s. Scientists will analyze them with tools far more powerful than those on rovers, searching for chemical signatures, fossils, or even isotopes that could indicate advanced technology. The stakes are enormous. A single discovery could rewrite an understanding of life in the universe, but there's a shadow over this quest. NASA's data is public, but not all of it is released immediately. Some samples, images, or findings could be held back, classified for reasons we can only guess. The Viking experiments, with their controversial results, raise suspicions that NASA knows more than it shares. The methane discrepancies between Curiosity and the trace gas orbiter fuel this unease. Why do ground-based measurements differ from orbital ones? Is it a technical glitch, or is something being overlooked or hidden? Let's step back and synthesize the evidence. Mars had water rivers, lakes, and possibly oceans for millions of years. It has organic compounds, preserved in ancient rocks. It has methane, fluctuating in ways that suggest an active source. These are the ingredients of life, found together in a way that mirrors Earth's most vibrant ecosystems. But Mars isn't Earth. Its life, if it existed, could be alien in ways we can't yet comprehend. Microbes are the simplest explanation. That the Viking results, the Cydonia anomalies, and the sheer scale of Mars' habitable past invite bolder ideas. Could a civilization have risen and fallen, its relics buried beneath the red dunes? Could it still be there, hidden in subsurface refuges? As we stand on the brink of these discoveries, Mars challenges us to think bigger. The curiosity and perseverance. Rovers are our eyes and hands, probing a world that refuses to reveal its secrets easily. The water, organics, and methane are clues, but they're only the beginning. In the next part of our journey, we'll explore the strangest features of Mars, the structures, patterns, and anomalies that suggest something more than nature at work. The red planet is glowing, and its story, far from over. The red planet has pulled us into its orbit, a world of ancient rivers, organic whispers, and methane mysteries that hint at life beyond our wildest dreams. We've walked through a Mars that once shimmered with water, where lakes reflected a thick atmosphere and canyons stretched like scars of a forgotten past. We've uncovered evidence: organic compounds, seasonal methane, fleeting briny flows that suggest something might have lived, perhaps still lies, in the shadows of this desolate world. We've even dared to question whether NASA, with its rovers and orbiters, holds secrets that could reshape our place in the cosmos. But now, we stand at the edge of a bolder question. What if Mars wasn't just home to microbes, but to a civilization? What if intelligent beings walked its surface, built monuments, or even harnessed the stars? Let's dive into the heart of this mystery, exploring the tantalizing possibility that Mars holds evidence not just of life, but of an advanced alien society. Start with one of the most iconic images in space exploration: the face on Mars. In 1976, NASA's Viking 1 orbiter captured a photograph in the Cydonia region that sent shockwaves through the world. There, etched into the Martian landscape, was a structure that looked eerily like a human face: eyes, nose, mouth, staring into the void. It was a mile long, with shadows that gave it an almost sculpted appearance. NASA quickly dismissed it as a natural formation, a trick of light and erosion. But the image, released to the public, ignited a firestorm of speculation. Could this be a monument, a message left by an ancient Martian civilization? This question demands our attention. Was the face a coincidence or a deliberate creation meant to be seen? The Cydonia region, where the face resides, is a treasure trove of anomalies. Nearby lies the D&M Pyramid, a five-sided structure named after its discoverers, Vincent de Pietro and Gregory Molinar. This formation, visible in Viking images, looks strikingly geometric, with sharp edges and a symmetry that seems unnatural. Other features abound: mounds aligned in patterns, ridges that form grids, and what some call a fort or city complex. In the 1980s, researchers like Richard Hoagland, a vocal advocate for extraterrestrial theories, argued that Cydonia was a planned site, with alignments suggesting mathematical precision. Hoagland pointed to angles between the face, the pyramid, and other structures that match geometric constants like pi or the golden ratio. Mainstream science scoffed, attributing these to erosion and pareidolia, the human tendency to see patterns like faces in random shapes. But what if there's more to the story? Step back and consider the context. Mars, as we've learned, was once a wet, warm world with rivers, lakes, and an atmosphere that could have supported life for millions of years. If life emerged, it had time to evolve, perhaps beyond microbes into complex organisms or even intelligent beings. On Earth, life went from single-celled bacteria to humans in roughly 4 billion years. Mars had a similar window, especially during the Noachian period, 4.1 to 3.7 billion years ago, when water flowed freely. Could a civilization have risen in that time, building structures that endured even as the planet died? The Fay Sand Pyramid in Cydonia, though weathered by eons, could be remnants of such a society, their shapes hinting at a purpose we don't yet understand. Skeptics argue that erosion can create remarkable forms. Wine, water, and time can sculpt rocks into shapes that mimic human designs. The Mars Reconnaissance Orbiter, with its high-resolution camera, revisited Cydonia in 2006, showing the face to be a heavily eroded hill. The sharp features seen in Viking images were softened, blending into the landscape, yet this clarity didn't end the debate. Erosion can obscure details, masking artificial structures as natural ones. Imagine Earth's pyramids after billions of years of Martian wines, would they still look man-made? The truth may lie in the details, and Cydonia's anomalies keep the question alive. Why do these structures align in ways that echo mathematical precision? Why do they cluster in one region, as if marking a significant site? Explore other anomalies that fuel this speculation. In Elysium Planitia, orbiters have captured images of strange mounds forming triangular patterns. These Elysium pyramids, as some call them, appear too regular to be random. In Arsiemens, a volcanic region, we find the so-called tubes, long, hollow structures that could be lava tubes, but look eerily like tunnels or pipelines. The Curiosity rover, exploring Gale Crater, stumbled across a rock formation in 2019 nicknamed Starfleet for its resemblance to a human-designed symbol. Coincidence, perhaps, but Mars has a way of piling up coincidences that challenge our assumptions. These are pieces of a larger puzzle, each one asking, what if Mars was more than a dead planet? Push the boundaries further, connecting these ideas to the Dyson sphere concept. A Dyson sphere, proposed by physicist Freeman Dyson, is a hypothetical megastructure built by an advanced civilization to harness a star's energy. While Mars itself couldn't host a full Dyson sphere, could it have been a staging ground for such technology? Imagine a civilization that mastered energy manipulation, building outposts on Mars to tap into the solar system's resources. The Fay Sand Pyramid could be markers, beacons, or even power stations, their purpose lost when Mars' environment collapsed. To Viking images, low resolution as they were, hinted at structures that could fit such a narrative. Higher resolution images may have blurred the details, but they can't erase the possibility that Mars was a hub for something greater. Consider the idea of panspermia. If life on Mars wasn't native, could it have been seeded by an extraterrestrial civilization? Panspermia suggests that life, or its building blocks, could travel between planets via meteorites. Mars and Earth exchanged material during the solar system's early years, as evidenced by Martian meteorites like LH8401, found in Antarctica. This meteorite, studied in the 1990s, contains microscopic structures that some scientists believe could be fossilized bacteria. While the scientific community remains divided, the idea that Mars and Earth share a biological history opens a stunning possibility. What if an advanced species seeded life on Mars or used it as a testing ground? The structures in Cydonia, Elysium, and Arsiemens could be relics of such an experiment, abandoned when the planet became uninhabitable. Look at the timeline. Mars' wet, warm phase lasted millions of years, long enough for life to evolve from simple microbes to complex forms. On Earth, intelligence emerged after billions of years, culminating in humans who built cities, machines, and spacecraft. Could Mars have followed a similar path? The Mariner 9 mission, which revealed the scale of Valles Marineris, also showed a planet with a violent past volcanoes, craters, and floods that reshaped its surface. Could some of these events have been influenced by intelligent activity? The tubes in Arsiamens, for instance, could be natural lava tubes, but their size and structure invite speculation. Could they have been shelters, transport systems, or storage for an advanced society? The Viking missions added fuel to this fire. Beyond the face, they captured images of other anomalies, ridges, grids, and mounds that seemed too orderly for nature alone. The Mars Global Surveyor and Mars Reconnaissance Orbiter later provided clearer images, but clarity doesn't always resolve questions. In the Neely Fosse region, scientists found clay minerals formed in water-rich environments, ideal for life. Nearby, orbiter images show patterns that some call terraced walls, with steps and angles that look engineered. Erosion, perhaps, but these are the ghosts of a civilization that might have thrived when Mars was green. Dive deeper into the Cydonia debate. Richard Hoagland and his colleagues propose that the region's features form a complex with astronomical alignments, pointing to stars or constellations significant to an ancient culture. While mainstream science dismisses this as speculative, the alignments are intriguing. The face and pyramid line near a feature some call the city, a cluster of mounds arranged in a grid-like pattern. Mathematical analysis, though controversial, suggests these features align with angles found in sacred geometry. Could this be a coincidence or a deliberate design meant to signal intelligence? These questions deserve exploration. Another anomaly is the Inca city in the South Polar region, a series of ridges that resemble a planned layout. Discovered by Mariner 9, these ridges form right angles, evoking the image of a city's streets. NASA attributes them to tectonic fractures, but their regularity raises eyebrows. Could they be the remains of a settlement buried under ice and dust? The Curiosity rover's Starfleet rock, though small, adds to the pattern. These anomalies, scattered across Mars, form a tapestry of questions that science alone can answer. They are invitations to dream bigger, to imagine a Mars that was once alive with purpose. Connect this to the broader universe. If Mars hosted a civilization, where did it go? The planet's decline, its loss of atmosphere, water, and warmth would have been catastrophic. Could its inhabitants have fled, seeking refuge on another world? Earth, just one orbit away, is a candidate. The panspermia hypothesis suggests life could have traveled between the two planets. Alternatively, could they ever treated underground, living in subsurface habitats powered by geothermal energy? The InSight lander detected seismic activity, hinting at a geologically active Mars. Could these quakes signal hidden enclaves, preserving the remnants of a lost race? Return to the Dyson sphere concept. If a Martian civilization was advanced enough to build megastructures, could they have left traces we're misinterpreting as natural? The tubes in Arsiamens, for instance, could be part of a larger network designed to harness volcanic energy or store resources. The Mars Express orbiter found evidence of subsurface lakes beneath the South Pole, liquid water preserved in a frozen world. Could these lakes be hideouts, sustaining a civilization that outlasted Mars' surface collapse? These ideas, though speculative, align with the evidence we've uncovered: water, organics, and anomalies that defy simple explanations. The Viking experiments, particularly the labeled release test, add another layer. The controversial results, which some believe indicated life, could suggest a civilization's legacy: microbes or chemical markers left behind. The Curiosity rover's methane spikes, fluctuating with the seasons, might be the breaths of surviving organisms or even artificial processes. If a civilization existed, it could have engineered systems to maintain life underground, producing methane as a byproduct. These ideas, though bold, fit the pattern of a planet that refuses to be fully explained. As we stand at this crossroads, Mars beckons us to look closer. The face, the pyramid, the tubes, and countless other features are more than rocks. Their questions etched into the planet's surface. Whether these structures are natural or artificial, they challenge us to rethink what's possible. Mars isn't just a dead world, it's a mystery that could redefine our place in the universe, and we're only beginning to unravel its secret. The Red Planet has revealed its secrets slowly, like a reluctant witness to a cosmic mystery. We've journeyed through a Mars that once flowed with rivers, shimmered with lakes, and pulsed with the potential for life. We've uncovered organic compounds, methane spikes, and ancient water systems that hint at a world not so different from our own. But as we stand on the brink of these discoveries, a shadow looms over the story of Mars, a question that lingers in the minds of scientists, enthusiasts, and skeptics alike. Is NASA telling us everything? Could the agency, with its decades of missions and mountains of data, be holding back evidence of life, microbial or otherwise, that would change our understanding of the universe? Or is there something even bigger, something tied to the whispers of UFOs and ancient civilizations locked away in classified files? Let's start with the most tangible piece of this puzzle, the Mars Sample Return Mission. NASA's Perseverance rover, tirelessly exploring Jezero crater, has been collecting samples, Martian rock and soil since 2021. These samples, sealed in titanium tubes, are no ordinary rocks. They come from a crater that once held a lake, a delta rich with clay minerals that could preserve signs of ancient life. The plan is ambitious. NASA, in collaboration with the European Space Agency, aims to bring these samples back to Earth by the early 2030s. Laboratories with tools far more advanced than those on rovers will analyze them, searching for microfossils, chemical signatures, or perhaps something stranger. Imagine the moment when a scientist cracks open a Martian rock and finds evidence of bacteria or something that defies all expectations, like a fragment of technology from a long-lost civilization. But here's where the questions begin. NASA's missions are public, funded by taxpayers, and their data is shared widely. Yet the process isn't instantaneous. Samples collected by Perseverance won't reach Earth for years, and even then, the analysis could take months or longer. What happens in the meantime? Could preliminary findings, say, a hint of biological activity, be withheld until NASA is certain? Or could they be classified, deemed too sensitive for public release? The idea isn't as far-fetched as it sounds. NASA operates within a broader framework of government oversight, and space exploration has always been tied to national security. If evidence of life, especially intelligent life, were found, it could have implications far beyond science, political, cultural, even existential. Let's step back to the 1970s, when the Viking landers touched down on Mars and conducted the first direct experiments to search for life. The labeled Release experiment, designed by scientist Gilbert Levin, produced results that stunned the team. When Martian soil was mixed with a nutrient solution tagged with radioactive carbon, it released a gas that matched the signature of biological activity. On Earth, this would be a clear sign of life. Levin was convinced he had found microbes, but NASA's official stance was cautious. The agency attributed the results to chemical reactions, likely involving perchlorate salts, found in Martian soil that can mimic biological signals under certain conditions. The debate raged for decades, with Levin arguing, until his death in 2021, that Viking had detected life. Why was NASA so quick to dismiss the findings? Was it scientific rigor, or something else, a reluctance to announce a discovery that could upend our view of the universe? The Viking controversy set a precedent. It showed that even compelling evidence could be sidelined, explained away as chemistry rather than biology. Fast forward to today, and we see similar patterns. The Curiosity rover's methane spikes, detected in Gale Crater, or another enigma, methane, a gas often linked to life on Earth, fluctuates on Mars in ways that defy easy explanation. In 2019, Curiosity recorded a massive spike, 21 parts per billion, the highest ever measured. Yet the European Space Agency's Trace Gas Orbiter, designed to map Martian gases, detected no such spike from orbit. This discrepancy has puzzled scientists. Is Curiosity picking up localized bursts, too small to be seen from space? Or is there a deeper issue, perhaps a deliberate omission in the data shared with the public? This brings us to a broader question. What does NASA know that we don't? The agency has sent orbiters, landers, and rovers to Mars for over half a century, amassing petabytes of data, images, spectro, chemical analyses. Most of this is public, accessible on NASA's websites, but not all data is released immediately. Some images are held back for processing, some findings are embargoed until peer review, and some may never see the light of day. Why? Calibration, errors, incomplete analysis, or national security. The last possibility, though speculative, isn't without precedent. Space exploration has always been intertwined with military interests. The Apollo program, for example, was as much a Cold War flex as a scientific endeavor. Could Mars data be subject to similar filters? Let's explore this further through the lens of UFOs, a topic that has long fascinated you. In recent years, the US government has declassified documents and videos related to unidentified aerial phenomena UAPs, the modern term for UFOs. In 2021, the Pentagon released a report admitting that 140 UAP incidents could not be explained by known technology or natural phenomena. Some of these incidents involved objects moving at hypersonic speeds, defying Earth's physics. While the report didn't mention Mars, it raised a critical question: if advanced technology exists in our skies, could it have a connection to the red planet? Mars, with its ancient water systems and mysterious structures, is a natural candidate for speculation. Could NASA have encountered evidence, say, an artifact or signal that suggests extraterrestrial activity, past or present? The Viking images of the Cydonia region, particularly the face on Mars, have fueled such theories for decades. When the image was first released in 1976, it sparked a firestorm of speculation. The face-like structure, with its eerie human-like features, seemed too perfect to be natural. NASA called it a trick of light, and later high-resolution images from the Mars Reconnaissance Orbiter showed it to be a weathered hill. But the debate didn't end there. Some researchers, like Richard Hoagland, argued that Cydonia was a plant complex, with the face, the D&M pyramid, and other features aligned in ways that suggested intentional design. While mainstream science dismisses this, the idea persists because Mars keeps surprising us. Anomalies, like the Starfleet rock formation, spotted by Curiosity in 2019, or the tubes in Arsiemens, keep the speculation alive. Could these be natural, or are they relics of a forgotten civilization? Let's consider the Mars sample return mission again. The samples Perseverance is collecting could hold definitive evidence of life fossils, chemical markers, or even something artificial. But what if NASA finds something it can't explain? A microfossil would be groundbreaking, but a fragment of metal, a tool, or a structure with unnatural properties would be earth-shattering. The agency's protocols for handling such discoveries are unclear. Would they announce it immediately, risking public panic or geopolitical fallout, or would they classify it, sharing only with a select few? The history of space exploration offers clues. During the Apollo missions, astronauts reported seeing unexplained lights and objects, some captured on film. These incidents, detailed in declassified NASA transcripts, were never fully explained. Could Mars hold similar secrets? The methane mystery adds another layer. Methane is unstable in Mars' atmosphere, breaking down under ultraviolet radiation within a few hundred years. For it to persist, something must be producing it, either geological processes like serpentinization or biological activity. The seasonal nature of Curiosity's methane spike suggests an active source, possibly underground. On Earth, microbes in subsurface environments produce methane. Could Mars have similar ecosystems, hidden in aquifers or geothermal vents? If so, why hasn't NASA prioritized drilling deeper? The InSight lander, which studied Mars' interior from 2018 to 2022, detected seismic activity, hinting at a geologically active planet. Could these quakes be linked to subsurface processes that sustain life or conceal it? This brings us to a darker possibility. If NASA has evidence of life, especially intelligent life, it might face pressure to keep it quiet. The Brookings Report, a 1960s study commissioned by NASA, warned that discovering extraterrestrial life could destabilize society. It recommended preparing the public carefully, suggesting that some findings might need to be withheld. While the report was speculative, it reflects a mindset that persists in government circles. The 2021 UAP report, with its admission of unexplained phenomena, shows that even today, transparency is limited. If Mars holds evidence of a civilization, say, a buried city or a signal, would NASA share it, or would it be buried in classified archives? Let's explore one final angle: the role of public perception. NASA's funding depends on public and political support. Announcing evidence of life, especially intelligent life, could spark reactions ranging from awe to fear. Religious groups might protest, governments might scramble to control the narrative, and conspiracy theories would explode. The Viking experiments already showed how controversial even microbial evidence can be. If Perseverance's samples contain something undeniable, a fossil, a tool, or a message, NASA might hesitate. waiting for the right moment or the right protocol. In the meantime, the public is left with fragments of data, like methane spikes or Cydonia images, and a growing sense that we're not being told the full story. As we close this chapter, the question remains, what does NASA know? The Perseverance samples, the Viking results, the methane anomalies, and the Cydonia debate all point to a planet that holds more than it reveals. Mars is a world of secrets, and while NASA has brought us closer than ever, it may also be the gatekeeper of truths too big for us to handle. The red planet continues to call, daring us to ask the questions that matter most. Are we alone, or is the truth already in our hands, waiting to be unveiled? Mars has taken us on a journey through time, from a world of flowing rivers and shimmering lakes to a barren desert whispering secrets of a lost past. We've explored its ancient waters, carved into canyons like veils marineris, and uncovered clues that paint a vivid picture of a planet that once pulsed with the potential for life. Organic compounds, hidden in the rocks of Gale Crater, hint at the building blocks of existence. Methane spikes, dancing in the thin Martian air, suggest something active, perhaps alive, beneath the surface. And then there are the anomalies that face in Cydonia, the strange mounds and patterns that make us wonder if Mars was ever home to more than microbes, perhaps a civilization that gazed at the stars as we do. But the question lingers, does NASA know more than it's telling us? Are the samples collected by Perseverance, sealed in titanium tubes, hiding evidence of life or something even stranger that could rewrite our place in the cosmos? This is where you come in. What do you think Mars is hiding? Were its ancient waters teeming with microbes, or did intelligent beings walk its shores, leaving monuments buried under red sand? Is NASA holding back, keeping the truth locked in classified files, or are we just beginning to scratch the surface of a planet that refuses to reveal its full story? At Zebo Alien, we're obsessed with these questions, and we want to hear your thoughts. Drop a comment below. Tell us if you believe Mars was once alive, if the face is more than a rock, or if Perseverance will uncover something that changes everything. Your ideas fuel our cosmic journey, so let's start a debate that reaches the stars. If this mystery has gripped you, smash that like button and share this video with anyone who dreams of the unknown. But the adventure doesn't end here. At Zebo Alien, we're diving deeper into the universe's greatest enigmas. Tomorrow, we're tackling a mystery so vast it dwarfs even Mars, the great attractor, a force pulling our entire galaxy toward an unseen point in the cosmos. Is it a supermassive black hole, a web of dark matter, or something beyond our comprehension? Subscribe to Zebo Alien and hit the bell to join us for this mind-bending exploration. Every video on this channel is a step into the unknown, a chance to uncover truths that challenge what we believe is possible. Thank you for exploring Mars with Zebo Alien. This is more than a channel, it's a community of curious minds asking the big questions. If you're ready to keep unraveling the universe's secrets, subscribe now and let's venture into the void together. Mars is just the beginning. What's out there, waiting for us to find? Keep looking up, and we'll see you in the next cosmic mystery.